Okay, 43. 43 again, we have to put the right hand side like a 0. Okay, now let's find the LCD. But for finding the LCD, I need the factorization of this expression. Critical common factor is 3. The LCD is obvious, que es 3 times x minus 2, x minus 3. Que es the multiplication every factor. So now when you divide this divided by this is 3 times x minus 3 minus 2 times x minus 2 less than 0. Okay, the rest is only distributive property. Okay, it's 3x minus 9 minus 2x plus 4 over 3x minus 2, x minus 3. See, when you combine like term, we have 3x minus 2, x minus 3. This is 3x minus x is only 1x. And negative 9 and 4 is negative 5. Less than 0. This is our expression. Okay, we investigate. Okay. Let's compute the critical value. The critical value, remember, is the 0 of the numerator. It's obvious. It's 5. This is our critical value. And the restriction is the 0 of the denominator. I don't care these 3. It's not important. Then it's 2 and 3. The restriction. 2 restriction. Okay. Now we're using the restriction and critical value for doing the partition. This is the partition or real number. Positive infinity, negative infinity. The critical value and restriction are 2, 3, and 5. 2, 3, and 5. 2, 3, and 5. 4 and 5. Now we select a testing point. A testing point maybe is 1, maybe it's 2.5, and maybe 4, and maybe 6. After that, we are doing the chart. Okay, we have no space for the chart. Let me erase this part. I suppose you copy. Si you don't copy, you review again the video. Okay. Let's do in the chart here. The chart is testing point. Testing point R1, 2.5, 4, and 6. And the factor we have to investigate is x minus 5, x minus 2, x minus 3, and the total sum. I don't care these 3, because these 3 do not apport any information about the change of sign chart. Okay, let's plug in. 1 here is negative, 1 here is negative, 1 here is negative, 3 negative is negative. 2.5 here is negative, 2.5 here is positive, 2.5 here is negative, is positive. 4 is negative, 4 is positive here, because 4 minus 2 is 2 positive. And this is 1 is positive, therefore it's negative. 6 is positive, positive, and positive, therefore it's positive. Okay, then The true part, according to our equation, is less than 0, is negative. So this is the true part, and this is the true part. The rest is false. Okay, don't care. Now, let's highlight this interval. The interval solution is when you have negative, when positive 1 here is the interval solution. One more is in solution, it's true here, and it's 4. Good. Now, our inequality is a strict inequality, have no equal, therefore do not contain any endpoint. But the solution is from negative infinity, comma 2, open, union, 3,5. This is synonymous to say x such that x is less than 2, or x is in between 3 and 5, and not included the endpoint in 3 and 5. Okay, 45. Let's determine the critical value. The critical value is obvious as 0. Remember, the critical value is the 0 of the numerator. I know the critical value is -3. I know the critical value is -4. This is the critical value. And the restriction is the 0 of the denominator is -5 and +1. Okay, restriction. Using this information, we are doing the partition of the whole real number line. All real number line. The partition is in 0, -3, -1, -2, -3 here. One more, -4, and -5, and +1. So we have 1, 2, 3, 4, 5. 5 value, therefore we have 6 testing point we need. For example, -6 is good testing, and between -5 and -4 is -4.5, and between -4 and -3 is -3.5. Maybe in between -3 and 0, maybe -1, and between 0 and 1/2, 0.5, and after 1, 2. Then let's do in this chart. The chart is long. The chart is, let me try, testing point. The different testing point we have are -6, -4.5, -3.5, -1, 1/2, or 0.5, and 2. The factor we have in our problem are x squared, (3 + x), x + 4, x + 5, and x - 1. And of course the extra column is the total sign. Okay, let me finish the chart. Okay. It's so be okay, this column is always positive. Because it's a square. Let's analyze the rest. This is negative 6. Negative 6 here is minus. Here is minus. Here is minus. And here is minus. 4 minus. Plus. 4.5 is minus here. Is minus here. Is 4.5 here is plus. Is minus here. 3 minus. Is minus. 3.5 is minus. Is plus. Is plus. Is minus. 2 minus is plus. 1 is plus, because it's 3 minus 1 is 2. Is plus. Is plus. Wait. Negative 1. Negative 1 here. Negative 1 here is the minus. Good. Entonces es negative. 1/2. 1/2 is positive. Is positive. Is positive. And 1/2 here is negative. Therefore it's negative. Okay. And finally 2 is positive. Is positive. Is positive. And this is positive also. Therefore it's positive. Okay. Now let's see what part is true and what part is false. Remember, it's true the part que is greater than 0, entonces que es positive. Entonces es positive. Here this part is true. This part is true. And this part is true. The rest no. Okay. Let me use another color. It's true this interval. This is true the interval 3.5 here. This interval. And it's true the last interval, because the interval can include 2. Of course, from 1 to infinity. Okay. And what about the endpoint and another extra point? Remember, this inequality is not a strict inequality. This is combination, inequality and equation. Therefore, the critical value belongs to the solution. The critical value, that 0 is solution. That 0 is one isolate point here, solution. Negative 3 is solution. Bracket, you indicate using bracket in this case. Negative 4 is solution. The rest no solution because they are restriction. Negative 5 no. 1 no. Okay, entonces the interval notation is from negative infinity, comma, negative 5, union, bracket, negative 4, comma, negative 3, union 0, que es isolated point, union, parenthesis, 1, comma, infinity. Okay, and the set notation, the same representation is the value of the x, such that x is less than negative 5 or comma. X is in between, include both endpoints, negative 4 and negative 3, or 0, que is one isolated point, or x greater than 1. This is the answer.